Hello, college algebra friends. This is Miss Backfish, and I am here to help you with 1, 2, 3, 4, 5, 6 questions that have been sent to me via Ask My Instructor, which is awesome. I love getting questions from you because that way I know what it is we need to focus on. So here's the first one. It says solve and check the linear equation, and I'm reading it kind of slowly because I'm writing it down on my paper as I do. 3 times the quantity x minus 4, that just means x minus 4 is in parentheses, minus 4 times the quantity x minus 3 equals x plus 3 minus the quantity x minus 5. Now, I can just about guarantee from looking, just from writing this problem down, that I know where the most likely spot for anybody to trip up on this problem is. Okay, here is that spot. There's a minus in front of a set of parentheses. That is a very common error for folks to make, is not to handle this correctly. When you have that minus in front of a set of parentheses, it basically acts as if, let me use another piece of paper here, it acts just as if this says x plus 3 plus negative 1 times x minus 5. Those work exactly the same way. That minus is like a negative 1 that I'm going to need to distribute to both terms here. Okay, I wrote too close to the top of the paper, sorry. All right, so that's what I'm going to do here, is I'm going to distribute that negative, or that minus. When I get there, I'm going to go ahead and write it right now so I don't forget though. Okay, so here I need to distribute the 3. Here I need to distribute the negative 4. There's nothing to distribute here. So let's go through and simplify what we have so far. 3 times x minus 3 times 4. That was here. Minus 4 times x minus 4 times negative 3. The minus 4 times the negative 3 gives me plus 12. Over here I have x plus 3. And then the minus times the x, it's like negative 1 times x, so minus x. The negative times the negative, the minus times the minus here, that's like negative 1 times negative 5, so this is a plus 5. That's a very important part of this problem. All right, so let's combine our like terms. That's what adding and subtracting basically is. Minus 12 plus 12. That makes 0. I don't have to worry about it anymore. Over here, positive x minus x. Again, that makes 0, so I don't have to worry about those either. So let's see what's left. 3x minus 4x. 3 minus 4 is negative 1x. You don't really have to write the 1, but I did. Equals 3 plus 5. So there's 8. Next thing I need to do, x is not by itself. Solving always means get this by itself. So I'm solving for x. I need to get x by itself, and x is not there yet. So what I need to do is I have to divide, or you could multiply by this negative 1 to get it out of the way. If I multiplied both sides by negative 1 there, the negative 1 would go away, or dividing both sides by negative 1. Either way, I get x equals the opposite of 8, or negative 8. And that's my final answer. And that's what we see right over here. Now there's another question that I was asked that is very, very much like this question. So let me find that one. Here it is. Solve and check the linear equation. It looks so much like that last problem. If you haven't done this one, or if you want to, regardless, go ahead and hit pause and try this one now that we just talked about how to do the last one. I'm busy writing for a moment. It has the same obstacle we had in the last one with that minus in front of parentheses. Always be very careful when you see a minus in front of parentheses, that you stop and take it seriously and think about what that's going to do. So here we go. I've got 2 times x, 2x. 2 times negative 3 is negative 6. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. X plus 2 minus x minus minus, negative 1 times negative 6, makes plus 6. So again, I have this great situation where I have stuff canceling out or adding to 0. Negative 6 and positive 6 adds to 0, so that disappears. Positive x and negative x adds to 0, so that disappears. So that means that on the left side of this equation, I have 2x minus 3x, which is negative 1x, or just negative x. And on the right-hand side, I have 2 plus 6. It's actually going to work out to be the same solution, isn't it? I wrote it differently this time, partly because we talked about the negative 1 isn't necessary there, also because I wanted to remind you of what this means. When you have a negative symbol in front of a variable, it doesn't really mean that this is going to be negative. This doesn't tell me that x is negative. It tells me that I want the opposite of x. In other words, this says the opposite of x is positive 8. Well, if the opposite of x is positive 8, then x must be negative 8. And we could have gotten there by dividing both sides by 1 or multiplying both sides by 1. But every time you see a variable that has a negative symbol in front of it, that means the opposite of whatever the value of that variable is, because the value of the variable could be negative or could be positive. So this is not saying that this is negative. It's saying we're going to take the opposite of whatever value x has. All right, on to another type of problem. Here is another one I was asked about, and one of the things I like problems like this because I like the fact that it sort of simplifies so neatly. It becomes so much simpler if we just know what to do with it. Here's what we're going to do with it. What's special about this is I have fractions. I have several different denominators. I have 5, I have 10, I have 2. They're all denominators. So what I'm going to do is I am going to think about if it were that I was looking for a common denominator. What would the common denominator be? Another way of saying that is I want the least common multiple of those denominators. Okay, the least common multiple, the smallest thing that all of them go into in the way that like 3 goes into 9 or 5 goes into 15. So 15 is a multiple of 5. So for instance, multiples of 2. 2, 4, 6, 8, 10, 12, etc. And let me go ahead and change my screen here since I have it written down. There we go. Multiples of 2, 2, 4, 6, 8, 10, 12, etc. Which ones of those are also multiples of 10? Or which ones of those are also multiples of 5? Well, it just so happens here that 10 is a multiple of all of these things. 10 times 1 is 10, 2 times 5 is 10, 5 times 2 is 10. So 10 is going to be my least common multiple. So that means 10 is going to be the thing that I'm going to multiply each of these fractions by. Now remember that 10 means the same thing as 10 over 1. So if you are multiplying by 10 over 1, then really the numerator of your fraction is getting multiplied by 10. The denominator is being multiplied by 1. So the denominator is not going to change. So really this is just kind of like multiplying by 10 on top. Okay, that's 10 over 1 times every term. Remember, you're allowed to multiply whatever you want times both sides of the equation, as long as you do it to both sides. Next thing that happens here is the beauty of this type of situation. Every single denominator is going to divide into its numerator. It's going to simplify so that it's gone. In other words, we have, I'm juggling for pens here, 10 over 5. Well, 5 goes into itself once and into 10 twice. We have a 1 in the denominator. You don't have to write a 1 in the denominator. Remember over here we said 10 means 10 over 1. We don't write 1s in every denominator. So no more denominator. This is fine as it is. 10 over 10, again, there's a 1 in my denominator. No more denominator. 10 over 2 is 5. 2 goes into itself once and into 10 5 times. So now you've got to be very careful to look at what is left. So this is 2 times 2x minus 10 times x equals just plain x minus 5 times 35. And now I have a fraction-free equation. There are no more fractions. I can just solve this equation like any other two-step equation, basically. So 4x minus 10x, that's negative 6x, x minus 5 times 35. 5 times 35 is negative 175, I believe. Yeah. So this is what we have. I'm going to collect my x's on one side. If I have negative 6 x's and I subtract one more, I have negative 7 x's. That's the same as negative 6 x's plus negative 1x. This became 0, negative 175. Divide both sides by negative 7, and x equals, I believe, 25. If you have 7 quarters, you have $1.75. That makes sense. 7 times 25 makes 175. So x is 25. Now, be careful that whenever you have rational equations, meaning basically fractional equations, you have to make sure that you don't end up with any zero denominators. Now, this one isn't really rational, and we really don't have to worry about that because there are no variables in the denominator. So if you look at your denominators here, I have 5, 10, 2. None of those are going to equal 0, no matter what x equals. So it's really only when the denominators have x's in them that you need to go back and make sure that your x is not going to make any denominator 0, because it is never okay to have a 0 denominator. All right, and so here I would go, let's see, click 25. So the solution set is 25. Is it going to let me click? I guess it's not. It would have been nice if it did. But I would go ahead and type in 25. Oh, there we go. I just wanted to think about it a little bit. Still thinking. I promise I'm typing a 2. It's going to think about it a lot. Watch, any minute now it's going to say 222 because I've typed the 2 so many times. No. So let's give up on this, but I would type a 25 right in there and then say check answer. All right, next question. I received 2 questions that both talked about this type of problem, solve the system by the substitution method. What do I mean by this type? Well, first of all, they're both systems of equations. Okay, that's what they mean by system, is I have 2 different equations, and it's the same x and y that solves both. So that's a system of equations. And then the other thing is they both tell me to use the substitution method, so that is what I'm going to do. All right, the substitution method starts out by saying take one of your equations and get one of the variables in that equation alone. Okay, let me write here and then I can better show you what I mean. We're about to have a cat passing through, so let me not switch to the dock cam. Hopefully the cat can pass through this without upsetting my setup here. Okay. Here is my system of equations. I think I copied it down correctly. Now, what my goal is, if I'm going to solve by substitution, is to look at both equations and say, is there a variable in either equation that is by itself on one side? And yes. If there had not been, that would be the first goal, is to get one of the variables in either equation by itself. So, like, suppose this had been a much more complicated equation, I would probably go for that x, because I can get that x by itself pretty easily by adding 3y to both sides. But here, I don't even have to do that. I already have one of the variables isolated in one equation. That's step 1 of substitution. Step 2, so this is like prime setup for substitution. Step 2 is to say, okay, well, if y is equal to all this stuff, then that means in place of y, I can write all this stuff. I'm going to substitute whatever that variable that I got alone is equal to in place of that variable in the other equation. So in other words, if y is equal to this, then I'm going to use all of that to represent y in the other equation. So we have, I'm rewriting the first equation with this substituted for y. So I have x minus 3 times all of that instead of y, because all of that is equal to y, equals negative 2. Now what I've done here, and this is the purpose of substitution, this is the goal, is now I have an equation that only has one letter, one variable. We can't solve an equation until we have just one variable, and that's what I just did. I got it down to this is an equation that has only one variable, so I'm ready to solve for x. This needs to be distributed, so x plus 6x, negative 3 times negative 2 is positive 6. Negative 3 times 24 is negative 72 equals negative 2. This is a 1x. 1x plus 6x is 7x. I'm going to add 72 to both sides equals 70. And now I'm almost there. I can get x by itself by dividing both sides by 7, because it was 7 times x. Do the opposite of times. Opposite of multiplication is division. And I get x is 10. Now, we want the solution to the whole system, so we also need to have a y value. But we're almost there. Now, all we have to do to get the y value is to come back up here where y was alone and say, oh, okay, y equals negative 2 times whatever I just got for x plus 24. That's negative 20 plus 24, which is positive 4. So y is positive 4. Okay, now, notice please, let me move this out of the way. When it says type an ordered pair, these squiggly brackets, those are brackets, okay? When you have a solution set that has an x and a y in it, that was not the best choice, I don't think. There we go. The ordered pair that represents the solution to those two equations is 10, 4 with parentheses. An ordered pair always has to have parentheses. Never any kind of brackets, just parentheses. So if it tells me to type an ordered pair, and it said the solution set, the brackets are saying this is a set. So this is like the set of all the ordered pairs. But inside those brackets, I still need to indicate that the answer, that is my answer, that is my set, there's only one answer in the set, is 10, 4 with the parentheses around it. An ordered pair always has to have the parentheses. So if you get this one incorrect, very often it can be because of that. Be very careful. That if you are trying to, if they are wanting you to type it in set notation, which they specifically say, the solution set, and they've got those brackets, and then it says type an ordered pair, the ordered pair also needs to have the parentheses. Okay? One way you can think about this one, I like to look at it think about it what it looks like on a graph. These are both lines. Both of those equations are lines. The ordered pair 10, 4 is saying these two lines meet at the point 10, 4. It's the only ordered pair that is on both lines. It's the only x and y value that works for both equations. So if you ever go back in and to plug in to check and see if it works, make sure you check both. I'm going to go to Desmos and show you the graph of this real quick. Turns out I can't go to Desmos right now, so I apologize for promising something I can't deliver. But I can give you a rough sketch of what this would look like. In other words, and this is a very rough sketch, you have two lines. This line is like the y equals negative 2x plus 24. This line is like the x minus 3y equals negative 2. They meet at one point, and that point is 10, 4. So that's just an idea of what does the 10, 4 represent. The next question I was asked is the same type of problem, solving a system of equations by substitution. The difference here is that it's not quite as readily set up for substitution. Remember in the last one, we already had the y alone on one side, and I said that's the first step. This time we don't have that. Okay, if we look at what we have, I have 8x plus 9y, I've got 3x minus y. I don't have any variables alone on one side. However, I do have one that will be pretty easy to get alone, so that's what I'm going to do. If I move this y over to the other side, and I'm going to call that y plus 8. It's the same as 8 plus y. And then subtract 8. Now I have y alone on one side. So that was just the easiest one to get alone. The easiest variable to get alone on one side of the equation will always be one that doesn't have a number in front of it. If you have one that has just a 1 in front, or a -1 in this case, that's going to be the easiest one to get alone. So that was my first goal when solving by substitution, is to get a variable, doesn't matter whether it's the x or the y, whichever one's easier, alone on one side of one of the equations. Doesn't matter which equation. Now, I know that y is equal to 3x minus 8. So I'm going to go to the other equation, not the one I just worked with, but the other equation, and in place of y, I'm going to put 3x minus 8. Be careful about how you write that, because this is 9 times y, so that's going to be 9 times all of 3x minus 8, so it does need parentheses. In other words, this is going to become 8x plus 9 times 3x minus 8, instead of y, instead of 9 times y, it's 9 times all of that, which is equal to y, equals -2. So 8x plus 27x minus 72 equals -2. This is 35x minus 72 equals -2. Add 72. 35x equals 70, and x is 2. Remember, we're solving for two variables here, so we're not done yet. We just have the x. Now to find the y, the easiest place to go back and plug in for substitution is the place that you already got the y alone. Because if I put the 2 in right here, 3 times 2 minus 8 is going to give me y. So 3 times 2 is 6, minus 8 is -2, and that equals y. So these are my values of x and y as an ordered pair. That's 2, -2. It's always x first, then y in an ordered pair. So when I go to my solution set, the solution set is just going to have the set notation. So it's saying basically my solution is the set of these points, but there's only one of them, and that's 2, -2. That's how I need to type this in. This is another, sorry, I spoke before it was recording. This is another commonly asked question, because it's just a little different. It's something we don't ask a lot in this particular way, but I like it. I think it's kind of fun. It says after a 90% reduction, okay, so that means the price went down by 90%. You purchase a new sofa on sale for $80. What was the original price of the sofa? Okay, so we have the original price, and I'm writing, let me go ahead and move this up since you can see both. I'm going to move that down so you can still see the problem as well. All right, the original price minus a 90% reduction, and I'm just going to write it like this for a second. This is not really mathematical yet. Gives me the new price, the sale price, that's $80. What was the original price of the sofa? Now, I'm going to call the original price of the sofa X. X minus a 90% of reduction. 90% of what? 90% of the original price. If you buy something 90% off, you're taking 90% of the original price off. If it was originally $100, it would be minus $90, because 90% of $100 is $90. So 0.90 is how we multiply to get 90% of something, and it's 0.90 of the original price X. So my original price minus 90% of the original price equals X. Excuse me, equals 80. Now I'm going to factor out the X. I'm going to say, okay, so X times 1 minus 0.9. Because this is 1x, so x times 1 gives me x. And this is 0.9 times x, so x times 0.9 gives me 0.9x. Equals 80. 1 minus 0.9 is 0.1. So this becomes 0.1, and so I've got 0.1 times x equals 80. Divide both sides by 0.1, and I get, let's go ahead and do it. Uh-oh, sorry, microphone down. 80 divided by 0.1 is 800. So x is 800. So originally this sofa cost $800. It can be a really easy way, this can be a really easy problem to double check. It can be easier to think of it honestly in the final form, going back and looking at what happened, than it is looking at it this way. In other words, if I have $800 and I take 90% off, 800 times 90% is going to be $720. So I'm taking $800 minus the 720, and that gives me 80. So yes, this does make sense that the original price was $800. Now, let me give you a little tip on these, on questions like this, and it can be questions about reductions by a percentage or questions about adding a percentage, like maybe adding sales tax. Okay? When you are subtracting a percentage, another way of doing this, kind of a shortcut, if I take 90% off, then what percent is left? Remember, it takes 100% as the whole shebang. So if I take 90% off, then I'm left with 10% of the original price. That's what we have here. You can jump to this. In other words, the $80 price is 10%. 10%, 0.10 times the original equals $80. So for instance, let's do another one like that. If the final price is $30 and we had, let's say, 60% off, what was the original? Okay. So if we took 60% off, 100% minus 60% means how much is left? 40%. So there's 40% remaining. So 40% of the original price is what this is. This is how much was left after we took the discount off. So 0.40 of the original price equals $30. And I can divide both sides by 0.4. And let's see what that gets me. This calculator has seen better days, hasn't it? 75. The original price must have been $75. I can check my work. I can do, okay, $75 minus 60% off. Well, that's $75 minus 0.6 times 75. That's the discount. And that gives me 30, so that's correct. All right, just wanted to show you that little sort of shortcut, but you certainly don't have to use it. You can do it whatever way makes the most sense to you. I hope these problems have helped you, and I appreciate your sending them to me, and I will see you at our next synchronous session. Bye-bye.